Welcome to AI Podcast. I'm Ethan, and today we're unpacking a new EMNLP paper called DispatchQA.
DispatchQA, huh? Give me the one-liner. What's the big idea?
Small, fine-tuned language models can turn messy shopping queries into clean API calls for search, and do it with quality on par with big models while responding faster.
Faster is nice, but what does turn queries into API calls actually mean in plain English?
Think of it like filling out a smart search form. You say, I need blue running shoes under $50, and the model doesn't just pass your sentence to search. It fills the form fields. Query equals running shoes, color equals blue, price max equals 50, then hits the search engine.
So it's not writing an essay, it's dispatching the request with the right fields, hence the name.
Exactly. And the team, led by Joachim Daiber with colleagues like Ayan Sinha at Upwork, built a benchmark to measure two things together: how good the results are and how long the system takes.
Quality plus speed, right? Where did they test this?
In a realistic e-commerce setup built on the webshop dataset, they index roughly 1.2 million product entries and define a single search function with filters like price, category, brand, color, and so on. Then they ask models to generate a JSON call to that function from a natural language query.
Okay, but how do they decide if the results are actually relevant?
They use an LLM as a judge approach and checked it against humans first. On one e-commerce judgment set, agreement between the LLM judge and human graders was in the substantial range, and on their web shop sample, the LLM judge aligned with each human more than the humans aligned with each other.
So the judge isn't perfect, but it's consistent enough to scale evaluations. Got it. What models are in the ring?
A fine-tuned, small model, Llama 3.18 billion parameters, running locally. They compare that to API models like GPT-4 class systems and a couple of heavier reasoning-style options. They also try a few other small models for variety.
And the training for the small one, was that a big data job?
Surprisingly light. About 1,000 synthetic examples. They use a larger teacher model to generate paired data, a realistic shopper query, plus the matching function call. Then they fine-tune the small model with either a standard fine-tune or a lightweight LoRa adapter.
1,000 examples sounds tiny. Did it really move the needle?
It did. The fine-tuned 8 billion model matches GPT-4 class quality on their metrics while generally answering in the ballpark of a third of a second locally. The comparable API model lands closer to around half a second in their setup.
So roughly similar relevance, noticeably snappier responses. That matters in search where half a second feels slow.
Exactly. There's a nice systems detail, too. They measured network overhead for the APIs and kept the local tests on a single high-end GPU box. It's not perfect apples to apples, but they're careful about warm-ups and caching.
You mentioned they test more than just the model. What else did they poke at?
Structured decoding. When a model must output valid JSON, you can constrain generation to a schema. They tried several libraries. The SGLang approaches, like X-grammar and outlines, kept quality high and were quick. JSON former on this particular schema was significantly slower and hurt quality.
So the wrapper you use to keep the model inside the lines can make or break latency. That's one of those hidden levers.
Totally. Another lever was whether to paste the full JSON schema into the prompt. For closed API models, including the schema nudged quality up. For the small local model, repeating the schema actually made things slower and slightly worse. The author's read is that if you fine-tune the model on the schema, it already knows the shape, so you don't need to shove the whole thing into the prompt every time.
That's a useful production tip. Teach the model once. Don't reprint the manual on every request.
Nicely put.
What about the harder baselines, those reasoning-heavy models? Any surprises?
Accuracy was strong, but latency jumped into the multi-second range. Great for deep reasoning, not great for I'm shopping on my phone while walking to the train.
What does the underlying search stack look like? Dense retrieval magic or something more standard?
Classic BM25 over the web shop index. The point of the benchmark isn't to squeeze every last bit of ranking quality, it's to isolate the query understanding step. The model's job is to map the messy ask to the right filters. The search engine then does the obvious thing.
That's helpful. So if my company already has a decent search backend, this paper is about the translator in front of it.
Exactly. Picture it as a polite concierge who listens to what you want and checks the right boxes before handing your request to the hotel staff.
Let's talk limitations. Where should listeners be cautious?
First, scope. It's e-commerce only and English only. Second, they fine-tuned one base small model and sampled a limited set of APIs. Third, the same family of model is used as both teacher for data generation and as judge for evaluation, which can introduce subtle biases, even though they validated the judge against humans. And finally, latency comparisons are always environment sensitive.
All fair. Reproducibility, though, do they share the goods?
Yes, code, data, and train checkpoints are released, which is great for replication and extensions.
If I'm a search lead listening right now, what's the practical recipe?
Start by defining a clean function schema for your search, including the filters your users actually care about. Distill a small set of realistic queries and gold calls, either from logs or with a careful teacher model. Fine-tune a small model on those pairs. At inference time, use a fast, structured decoding library and avoid stuffing the full schema into the prompt if your model has already learned it.
And for teams that can't host a model locally?
You can still benefit with API models, especially if you include the schema in the prompt and keep your tool definition tight. You'll get solid quality, just not the same latency wins as a tuned local setup.
What future work did they point to?
Broadening beyond e-commerce, trying multilingual queries, testing with denser or hybrid retrieval stacks, and scaling the synthetic training beyond 1,000 examples to see how the curve moves. Also, running more human evaluation at scale to stress test the judge.
All right, bring it home. What's our takeaway?
If your product relies on sub-second search, you don't necessarily need a giant model to understand user intent. A small, fine-tuned model that speaks your API can match big model relevance and shave meaningful time off the response, provided you pick the right decoding strategy and keep your prompts lean.
Love it. Small models, sharp tooling, smarter prompts. That's the play.
That's DispatchQA in a nutshell. Thanks for listening to AI Podcast.
See you next time.